right, we've taken the derivatives of inverse trig functions. Now it's time to take integrals. At the end of this lesson, you'll be able to evaluate an integral involving an inverse trig function. Right, if you look at our formulas for integrals involving inverse trig functions, hopefully you notice that they again kind of go backwards. This time if we've got arc sine, you'll notice if I've got this, the left side is actually the derivative of the right side. So if I start with the derivative, then I really just end up with the other formula. Differences between the derivative formula and the integral formula. In the derivative formula, we have a 1 here. This time we'll actually have an A, and A is a constant. So we'll just put A is a constant. And just like what we're used to, U is going to be some sort of variable. So that's all we need to keep in mind. So basically what we're going to be doing when we do these problems, we're going to say, oh, is that the setup of an arc sine, an arc tangent, or an arc secant? And then we're just going to try to get our problem to fit the formula. And if the problem fits the formula, then we are all set to actually use the formula. So we're just going to go ahead and jump right into these problems and see how they work out. All right, evaluate the integral. This one, I notice that it fits the form of an arc sine problem. So that's what I want to make it fit. All right, so there are a few things that I need to identify. First of all, I need to identify my u, and my u is going to be the variable, which in this case would be x, because I'm turning this into u squared. My du, the derivative of x, would just be 1 dx. And then my a would be my constant, which in this case would be 2, because remember in my formula this says a squared, so we actually take the square root of that 4. Okay, if I'm looking at my parts here, I do just need to check mostly for du, and it is equal to 1 dx, so pretty much I have it there. So we can do this next step. I'm going to write this next step, but you won't need to write this every time. As long as it fits the pattern, you are all set. So 1 dx was du, and then the square root. This ended up being a squared minus u squared. So it does have the right setup. So my problem, the answer is going to be arc sine u over a. U is x in this case, a is 2, and then plus c. And then we are done. All right, next one. This one, if I had to pick, first of all, I'd probably see if I could do a u substitution for this one, just like a straightforward let u equal 1 minus t to the 4th. But if I did that, my derivative would be 4t cubed, and I don't have a t cubed up there, so I'm kind of stuck. So if I had to pick whether it looked like arctangent, arcsine, or arc cosine, I would probably, or excuse me, arc secant, I would pick arcsine. So that's the one that we are going to go for. So let's go ahead and identify our parts. My u, if I looked at down here, I know my u is going to have to equal t squared, so that when I square it, I'll get t to the 4th. Which means if I take the derivative of t squared, I will get 2t dt. And notice that's really why the t was sitting up top in the first place. And then if I identify my a would just be the square root of the constant, which is 1. So now I just need to make sure all my parts are set up. Du is supposed to be 2d dt, and I only have t, so I'm going to put a 2 on the inside and a 1/2 on the outside. So if I rewrite this, I have 1/2 2t dt turned into du, and then I've got the square root. 1 is a squared, and then this is u squared. So notice it's all set up to be an arc sine problem, so I'm just going to bring down my 1/2, and then it will be arc sine u over a, so it'll just be t squared over 1, and then plus c, and that will be my integral. All right, let's try another one. This one, again, I'd probably start out trying to do a u substitution, and I'd let u be the denominator. And if I did that, my derivative would be 4e to the 4x. And notice I don't have that up there, so that kind of makes me stuck. So if I had to pick whether it's going to be arc sine, arc tangent, or arc secant, I would pick arc tangent because of that plus sign. So let's try to set it up like an arc tangent problem. First of all, my u is my variable. So, and the square root of e to the 4x would just be e to the 2x. And then my a, the square root of 4 is 2. Whoops, I forgot to find my du. Let's go back and do that. The derivative of e to the 2x is 2 e to the 2x dx. All right, so let's just make sure my parts are there when I'm checking for my du. It's supposed to say 2 e to the 2x dx. This one just says e to the 2x dx, so I'm going to add my 2 in, which means I'm going to put a 1/2 on the outside. So I'll have 1/2, 2 e to the 2x dx turned into du. On the bottom, 4 was a squared, and e to the 4x was u squared. So now this is an arctan problem. So I can go ahead, it's going to be 1/2 because I'm bringing down that 1/2. In the arctan problem, it says to actually do 1 over a. So I'm going to do 1 over 2, arctan u over a, so e to the 2x over 2. And then I'm just going to simplify it a little bit. 1/2 times 1/2 is 1/4. Arctan e to the 2x over 2, and then plus c. All right, let's try one more problem. Okay, on this one, again, it just kind of looks like a big mess, and I'm not sure what to do with it, but it kind of looks like an arcsecant setup, so I'm going to attempt to set it up like an arcsecant problem. Okay, my u is the variable, the square root of the 4x squared, which is 2x, and then du, the derivative of 2x would just be 2 dx, and then my a would be the square root of the 25 is 5. So let's just make sure I have my parts. In the arc problem, it says du is equal to 2x dx. I have a 3, so I'm going to need to multiply by 2/3 to get it to say 3. So I'll have to do 3/2 on the outside. So I have 3/2. Now this will turn into du, and then on the bottom, 2x we already identified as being u, and then the square root 4x squared is the u squared, minus 25 is the a squared. So notice this is the identical formula that I want. It's the arcsecant setup. So I'll have 3/2 times 1 over a, and a happens to be 5, and then arcsecant, and this time we do have to put u over a in the absolute value. So u was 2x and a was 5. And then I'll just clean this up a little bit. This will be 3/10 arcsecant, the absolute value of 2x over 5, plus c. So hopefully now you can take the integral of an inverse trig function.